Alright, in this video I'm going to do another example of factoring polynomials by grouping. So once again, we factor polynomials by grouping when we have four terms. So notice that this example 2 has an x to the third plus 4x squared minus x minus 4. And when we factor by grouping, what we end up doing is we group the first two terms and we group the last two terms. And then we look for the greatest common factor in each of those groupings. So if I look at this first grouping, I want to think about what's the greatest thing that I can divide out of both of them. Well, right now, if I look at that, I can tell that I can divide out an x squared from both terms. And then I want to write in the parentheses what's left over when I divide out the x squared. So for instance, x to the third divided by x squared, well, that just leaves me with an x. And then if I take positive 4x squared divided by x squared, well, that just leaves me with a positive 4. And then in this second grouping, I have a negative x and a negative 4. So really the only thing I can divide out of there is a negative 1. And then if I take out a negative from the x, I'll be left with x. If I take out a negative from the 4, I'll be left with a positive 4. And then once again, usually when you're working with the greatest, or when you're taking out factoring by grouping and you just got done with the greatest common factor, you should kind of notice that these two parentheses are the same. So we can actually do the greatest common factor step one more time with this term and this term being separated by a subtraction sign. So what you'll notice is I can factor out an x plus 4 from both terms, and I'll actually go ahead and cross them off in this example, and you'll notice that will leave me with an x squared and a minus 1. So I can factor this into x plus 4 times x squared minus 1. Now, once again, we've completed the factoring by grouping, but sometimes the problem will want you to factor completely. And what that really means is that we have to keep factoring until there's nothing left to factor. So if I look at this second grouping once, I notice that I have an x squared minus 1, and 1 is the same thing as 1 squared. So here I also have the difference of two squares, so I can actually factor this further. Now there is a shortcut method for factoring the difference of squares, but I'm going to do it the expanded way. So I can write this out as x plus 4, and then I can actually expand this to be x squared plus 0 x's in the middle, and then minus 1 off to the side. And then I'll factor this trinomial completely, so I can rewrite this as x plus 4. And then I want to factor this trinomial, so I can make it x times x gives me the x squared. And then I want to think about what times what multiplies to negative 1 and adds to 0. Well, in this case, it'll be positive 1 and negative 1. And this will be the final solution for factoring this polynomial completely.